AC question or AC circuit question number 5 is a comprehensive question that contains 3 components whose different variables must be found. On the board is a very clear representation of the question we are talking about. A circuit consists of a resistor 500 ohms and a capacitor of 5 microfarad. 5 microfarad connected in series. If an AC voltage of 10 volts and frequency 50 Hz is connected across the circuits or is applied across the circuits, we are expected to calculate. The first one is the reactance of the capacitor. The second one is the total current flowing in the circuit. And the third one is the voltage across the capacitor. And finally, the impedance and voltage across the inductor. So we have 3 components to deal with. Alright? And we're going to do that. Very simple. So what we need to do, this whole big statement has been represented in a very simple schematic diagram. Right? Okay, with this, we bring out our data, what we have. Of course, in the question we have a resistor offering some amount of resistance, 500 ohms. We have an inductor, letter L, with 150 millihenry. Then a capacitor offering capacitance of 5 microfarad. Right? So we are asked to calculate the impedance. We are asked to calculate the reactance of the capacitor, the impedance, and then the voltage across the capacitor and the inductor respectively. So we're going to do that. What do we do? And remember, we only have 10 volts. The source is supplying 10 volts to the circuit. So we have V is equal to 10 volts. Then the frequency given is 50 Hz, all contained in the question. We have carefully extracted the content of the question. It is now time for us to use the appropriate formula to solve accordingly and get these various parameters that we have been asked to get or to find. So the first one is the capacitance of the capacitor. The capacitance of the capacitor can be calculated by using XC is equal to 1 all over 2 pi FC. That's the formula we are going to use to calculate the capacitive capacitance, the capacitive reactance, the capacitive reactance of the capacitor. All right, or simply put, the reactance of the capacitor. So let's go. We substitute, by the time we substitute, we have XC is equal to 1 all over 2, bracket open again, we take it deep, we put the value of pi 3.142, bracket close, and we have the value of frequency is 50 Hz, we substitute there, and then move on again, the value of the capacitor is 5 microfarad, and we should know that microfarad simply means 10 raised to the power minus 5. So we have 5 times 10 minus 5, then totally bracket close. Alright? So simple mathematical operation here will give us the answer directly. So we have this XC, capacitive reactance, or the reactance of the capacitor is given as 636.62. Alright? 0.62 ohms. 62 ohms. Of course, we need to understand, we should understand that reactance of the capacitor, the reactance of the inductor, and even the resistance of a resistor all are measured in ohms. So that's the essence of this. That's why we have ohms there. Okay? We have found the reactance of the capacitor as XC equal to 6 36.62 ohms. Solved. But we're not done yet. There is something we need to find. We are asked to find the current flowing in the circuits. We are asked to find the current flowing in the circuits, and we must do that. But we can't just find the current flowing in the circuit without knowing the total impedance, the impedance offered in the circuit. The impedance simply means the opposition offered by the reactance of an inductor, capacitor, and the resistance of a resistor in this RLC circuit. That's what it means to find impedance. So we are going to do that. Having done this, what do? We begin to find, first of all, we need to find the reactance of the inductor. Okay? We already know the resistance of the resistor, so we don't have problem with that. So what do? We go again, we clean up this to have space. Take note that we have found this, okay? Because very soon I'm going to clean it off and then solve towards that side. So we have to find the reactance of the inductor is given as 2 pi FL. With this, we substitute is equal to 2 is equal to 3.142, all right? And then the frequency is given as 50. The inductor itself is given as what? It's given as 150 millihenry. 150 millihenry. If we convert this, that is 150 over 1,000. I repeat, 150 all over 1,000 will give us 0.15 Henry. So if we do that, we have that already. So that becomes 0.15 Henry. All these together. By the time we simplify again, 2 times 3.142 times 50 times 0.15, the inductive reactance of the inductor is given as 47.13. That is what it's going to be. So let's put down that and then move on with our question. That's 47.13 ohms. Solved. So we've arrived at this. You can as well, while you are considering to subscribe, cross-check what I am doing. If there is any confusion anywhere, let me know. Put it in the comment section. Give me some thumbs up. Subscribe, come on. Put the bell button on for constant notification. Share with your friends. Share with your networks and students all over the world. Do that for them. Do them a favor. They need something like this. Come on. Thank you, my returning subscribers. And then thank you also, my new subscribers. You guys, you are amazing. We have not forgotten also that the source is always represented by V is equals to V naught sine omega t, and then the current being produced from such a source is also I naught sine omega t. Okay? So that is okay. Now we have found the capacitive reactance. We have also found the capacitive, the reactive, the reactance of the inductor. Excuse me. At times one can get started at times. So we have found the capacitive reactance. Good. We've also found the inductive reactance. Yes. Okay. Now, having found this, we are going to combine this with this, and then the value of the resistance or of the resistor. So, and then use it to find the impedance. So the next thing we are going to do now is to find the impedance. The impedance is very simple, and we're going to do that right away without wasting time, because that is the first step first before we can now find the total current flowing in the circuit. So impedance is given as Z is equal to root all this R squared plus brackets capacitive inductive reactance L minus capacitive reactance all squared. So that is it. Check that. If we understand this, we substitute. So let us not waste any time. We substitute. Z is equal to all this root. This is 500 squared bracket close plus. Okay? We move on. the value of the inductance, but this time around we're going to take this because it's going to affect something. We have 36.62 minus 47.13 all squared. Okay? I have substituted this value of the resistance, the value of the capacitive reactance first because it's bigger in value, and then minus the value of the inductive reactance. That is it. By the time we clear out all of this, and see what we have. The impedance is giving us very huge amount of value, which is 347. Okay, we have 3. Why is my chalk breaking this way? All right, my chalk is breaking, and I'm not comfortable with that. Okay, 3, 4, 7, comma. And then we have 998.5 ohms. Can you see? That's a very big value. Can you see the amount of impedance being offered in an AC circuit against the flow of current? That's great. So we have finally succeeded in finding the impedance. Now we can go on and find the value of current. Okay? So quickly we substitute and state the formula we are going to use to find the value of the current flowing. Look at it. It's very simple. The second one, the current flowing in the circuit is number 2. It becomes something interesting that current flowing in the circuit can only be calculated by using Ohm's law. Okay? This time, the impedance is taking the place of resistance according to Ohm's law. Okay? Because the impedance also is measured in ohms. It's very simple. So we substitute. For voltage is 10. For the impedance is 347,9. This is 99, okay? 998.5. By the time we do this, what do we have? Look at it. Let me write this well. By the time we finish, let me repeat this clearly. 998.5. That's what we have. That's what we have there, okay? So by the time we evaluate current, therefore, current flowing in the circuit is equal to simple calculation, point your calculator, 10 over this. 10 over this is going to give us 2.87 times 10 raised to the power minus 5 amps. Very small amount of current because the value is in negative, all right? It has zeros. 0.0000287. Okay, look at it. It has 0.000 into 5 places before we now have 287 amps. So it's very, very small. The amount of current flowing in the general circuit is very, very small. Because why? The impedance is too large, too big. This is interesting. I'm going to stop here, right? I will stop here. Next time in my class, we'll be looking at the third one, the voltage across the capacitor, and then voltage across an inductor, including the impedance. All right? We're going to find the impedance on the inductor. We've already done that, so we don't need to repeat that. It's already there. The impedance is 47.3.13. So we found the reactance. Okay, the reactance of the inductor, we've already found that. So in my next class, take notes. We're going to find the voltage across the capacitor. And we found the impedance and the voltage across an inductor of this value, which is this. So these are the two things we are going to resolve in my next class. Thank you for your patience. I'm sorry that this video is too long, but I must do that. Teaching is not just, shouldn't be done in a haste for one to be able to understand it. See you in my next class. It will be linked somewhere there or somewhere there. I sign out. Sign out now, but make sure you learn this and share to your friends, students, and network.